Before we start, let me say to you all who are standing up, who I assume are students at Herndon High School, is that accurate? Any chair that is not now occupied, you all should feel free to take. So if you want to come forward, you can fill up some of these seats in front or in the back right there as well in the middle. I don't want you to have to stand up this entire hearing. Of course, the students sitting in the chairs that say reserved for witnesses might be called to testify, but that's the chance. That's the chance you take. The Committee on Science, Space, and Technology will come to order, and welcome to today's hearing, Astrobiology and the Search for Life in the Universe. A couple of preliminary announcements. One is that I want to thank C-SPAN for covering this hearing today. That shows the importance of the hearing in a lot of respects. And I want to thank all the students from Herndon High School here as well. I understand you had a choice of hearings to attend. In fact, you could attend almost any hearing you wanted to, and you chose this one because you thought it was the most interesting. And actually, that is one of the purposes of today's hearing, and that is to inspire students today to be the scientists of tomorrow. And who knows, we may have some of those scientists in the audience right now who will be inspired by what they hear to study astrobiology or perhaps some of the other sciences as well. So we appreciate your attendance. I'll recognize myself for an opening statement and then the ranking member as well. As we discover more planets around the stars in our own galaxy, it is natural to wonder if we may finally be on the brink of answering the question, are we alone in the universe? Finding other sentient life in the universe would be the most significant discovery in human history. Scientists estimate that there are 80 billion stars in the Milky Way galaxy. To date, more than 1,700 nearby planets have been found by the Kepler Space Telescope. Last month, astronomers discovered the first Earth-like planet orbiting its star at a distance where liquid water could be present, a condition thought essential to life. Called Kepler 186f, it is only 10% larger than the Earth and about 490 light-years away. The Transiting Exoplanet Survey Satellite, which will launch in 2017, and the James Webb Space Telescope launching in 2018, will help scientists discover more planets with potential biosignatures. The United States has pioneered the field of astrobiology and continues to lead the world in this type of research. A sample of professional papers published in Science magazine between 1995 and 2013 illustrates the significant growth and growing popularity of the field of astrobiology. Between 1995 and 2012, the number of papers published on astrobiology increased 10 times, and the number of scientific reports that cited astrobiology increased 25 times. Astrobiology is a serious subject studied by serious scientists around the world. Reflecting this interest, next September, the Library of Congress and NASA will hold a 2-day astrobiology symposium on what the societal impacts could be of finding microbial, complex, or intelligent life in the universe. Whether life exists on other planets in the universe continues to be a matter of debate among scientists. Around the world, a number of astronomers listen to naturally occurring radio frequencies. They try to filter out the cosmic noise and interference of human-made satellites and spacecraft to find anomalies that could be signals from civilizations elsewhere in the universe. The Allen Telescope Array at the SETI Institute, financed by Microsoft co-founder Paul Allen, and the Arecibo Telescope in Puerto Rico are two well-known locations for conducting radio astronomy searches for life in the universe. Recently, radio astronomers have detected pulsed signals that last only a few milliseconds. These fast radio bursts, as they are called, have caused scientists to speculate as to their cause. Some scientists hypothesize they could be from stars colliding or from an extraterrestrial intelligent source. Other astronomers search for laser light pulses instead of radio waves. Researchers at the SETI optical telescope, run by the Harvard-Smithsonian Center for Astrophysics, the Columbus Optical SETI Observatory, and the University of California at Berkeley, among others, use optical telescopes to try to detect nanosecond pulses or flashes of light distinct from pulsars or other naturally occurring phenomena. I hope today's hearing will enable us to learn more about how research in astrobiology continues to expand this fascinating frontier. The unknown and unexplored areas of space spark human curiosity. Americans and others around the world look up at the stars and wonder if we are alone, or is there life on other planets. That concludes my opening statement, and the ranking member, the gentlewoman from Texas, Ms. Johnson, is recognized for hers.
Thank you very much, Mr. Chairman, and good morning. In the interest of saving time, I will forego making an opening statement, and instead I'll simply want to welcome Dr. Shostak and Dr. Wertheimer to this morning's hearing on the search for life, including intelligent life, in outer space. You both are distinguished researchers, and I know that you will have thoughtful testimony to present. And this afternoon we'll determine whether we'll have researchers to continue this. So thank you, and I yield back.
Thank you, Ms. Johnson, and I'd like to introduce our witnesses at this point. Our first witness, Dr. Seth Shostak, is a senior astronomer at the SETI Institute in Mountain View, California. He has held this position since 2001. Dr. Shostak has spent much of his career conducting radio astronomy research on galaxies. Dr. Shostak has written more than 400 published magazine and web articles on various topics in astronomy, technology, film, and television. He has also edited and contributed to nearly a dozen scientific and popular astronomy books. He has authored 4 books, including Sharing the Universe, Perspectives on Extraterrestrial Life, and Confessions of an Alien Hunter, A Scientist's Search for Extraterrestrial Intelligence. You can hear him each week as host of a 1-hour-long radio program on astrobiology entitled Big Picture Science. Dr. Shostak received his bachelor's in physics from Princeton and his PhD in astrophysics from the California Institute of Technology. Our second witness, Dr. Dan Wertheimer, has worked at the Space Sciences Laboratory at UC Berkeley since 1983. He is currently the director of several of the lab centers, including the SETI Research Center and the Center for Astronomy, Signal Processing, and Electronics Research. Additionally, Mr. Wertheimer serves as chief scientist for the lab's SETI at Home program and associate director of their Berkeley Wireless Research Center. Mr. Wertheimer co-authored SETI 2020 and was the editor of Bioastronomy, Molecules, Microbes, and Extraterrestrial Life, and Astronomical and Biochemical Origins and the Search for Life in the Universe. His research has been featured in many broadcast news stories, such as on ABC and CBS and many major newspapers and magazines. His work also has reached a younger audience through Scholastic Weekly, a science magazine for kids. Mr. Wertheimer received his bachelor's and master's degrees in physics and astronomy from San Francisco State University. I'll recognize, to start us off today, Dr. Shostak, and then we'll go to Mr. Wertheimer.
Thank you, Congressman Smith, for the opportunity to be here. I'm just going to give you a few big picture thoughts on the search for life, and in particular, intelligent life, the kind of life that could uphold its side of the conversation as opposed to the microbial sort of life. This is obviously a subject of great interest to many people. Let me just back up and say that when you read in the paper about the discovery of a new planet or something, water on Mars, you're looking at one of 3 horses in a race to be the first to find some extraterrestrial biology. The first horse is simply to find it nearby, and that's where the big money is. Rovers on Mars, the moons of the outer solar system, there are at least a half a dozen other worlds that might have life in our solar system. The chances of finding it, I think, are good, and if that happens, it'll happen in the next 20 years, depending on the financing. The second horse in that race is to build very large instruments that can sniff, if you will, the atmospheres of planets around other stars and maybe find oxygen in the atmosphere, or methane, which, as you know, is produced by cows and pigs and things like that, but biology in any case, and so you could find pigs in space, I suppose. that's, again, a project, depending on funding, that could yield results in the next 2 decades. The third horse in that race is SETI, Search for Extraterrestrial Intelligence, and that idea, if you've seen the movie Contact, you know what the idea is. It's to eavesdrop on signals that are either deliberately or accidentally leaked off somebody else's world. That makes sense because, in fact, even we, only 100 years after Tesla and Marconi and the invention of practical radio, we already have the technology that would allow us to send bits of information across light years of distance to putative extraterrestrials. Let me just tell you why I think they're out there, by the way. That is, it's unproven whether there's any life beyond Earth. That's the situation today. You've heard me say twice now that I think that situation is going to change within everyone's lifetime in this room. Okay, and the reason is the universe is very fecund with habitats for life. Congressman Smith has mentioned the number of stars in our galaxy. With respect, that number is actually rather larger. It's something like 200 to 400 billion stars, but we now know that at least 70% of them have planets. Recent results from NASA's Kepler telescope, an astoundingly successful instrument, suggest that 1 in 5 stars may have planets that are cousins of the Earth. What that means is that in our own galaxy, there are tens of billions of other planets that are the kind you might want to build condos on and live, all right? Okay, tens of billions. And if that isn't adequate for your requirements, let me point out there are 150 billion other galaxies we can see with our telescopes, each with a similar complement of Earth-like worlds. What that means is that the numbers are so astounding that if this is the only planet in which not only life, but intelligent life has arisen, then we are extraordinarily exceptional. It's like buying trillions of lottery tickets and none of them is a winner. That would be very, very unusual. And although everybody likes to think that they're special, and I'm sure you all are, maybe we're not that special. Certainly the history of astronomy shows that every time we thought we were special, we were wrong. So what has been done so far, we have had various kinds of radio searches. I won't detail the technology. We've looked at much of the sky at fairly low sensitivity over a limited range of radio wavelengths, radio sections of the band. We have looked in particular directions at a few thousand star systems. In other words, we have just begun the search. The fact that we haven't found anything means nothing. It's like looking for megafauna in Africa and giving up after you've only examined one city block. And the reason the search has been so cramped, so constricted so far, is simply, to be honest, the fact that there's no funding for this. It's all privately funded. The total number of people in the world that do SETI for a living is fewer than the number of people in any row in the audience here behind me. That's the world total for this endeavor. When are we going to find them? You've already heard me suggest that that may happen rather quickly. Let me just point out 2 other things. One, this is very interesting to the public because they've seen extraterrestrials on television and in the movies all their lives. Okay? That also gives it a certain giggle factor. It's very easy to make fun of this. On the other hand, it would have been easy to make fun of Ferdinand Magellan's idea to sail around the Earth or Captain Cook to map the South Pacific. It's exploration. That's what this is. The consequences are always, shall we say, salubrious. To find that there's life out there, intelligent life, would calibrate our position in the universe. It would, as Congressman Smith says, probably be the greatest discovery that humankind could ever make. And what's important is this is the first generation that has both the knowledge and the technology to do that.
Thank you, Dr. Shostak and Mr. Wertheimer.
Thanks for the opportunity. Thank you for the opportunity to talk to you about this question, are we alone? Is anybody out there? Can you guys show the slides? I want to walk you through some of the SETI experiments that we and other people are doing. As Seth mentioned, this NASA Kepler mission, from that we've learned that there are 1 trillion planets in our Milky Way galaxy. That's more planets than there are stars. Lots of places for life. And we've learned that a lot of these planets are what we call Goldilocks planets, at the right distance where it's not too hot, not too cold, rocky planets. Some have liquid water. So there could be a lot of life out there. So how are we getting in touch? Well, one of the ideas is that Earthlings have been sending off radio, television, radar signals out into space for the last 75 years. The early television shows like I Love Lucy, Ed Sullivan have gone past 10,000 stars. The nearby stars have seen The Simpsons. So you could turn that around. If if we're broadcasting, maybe other civilizations are sending signals in our direction, either leaking signals the way that we unintentionally send off signals, or maybe a deliberate signal. They could be sending laser signals, and there are a number of projects looking for laser signals. This is a project at Harvard University, a very clever project. This is a project at Lick Observatory. There's also a project at in Hawaii at the Keck Telescope looking for laser signals. People are also looking for radio signals. Our group uses the world's largest radio antenna. We call it a radio telescope. This is the Arecibo telescope in Puerto Rico. It's 1,000 feet in diameter. It holds 10 billion bowls of cornflakes. We haven't actually tried that. It's operated by the National Science Foundation, and most astronomers would be lucky to use this telescope a day or two a year. And we figured out a way to use the telescope at the same time that other scientists are using it, so we can actually collect data all year round, all day. We're collecting data right now as we talk to you. Now that is actually a problem. So even though we get the world's largest telescope all year round, it creates an enormous amount of data. And to analyze that data, we ask volunteers for help. If you can help us by running a program on your home computer, your laptop, or your desktop computer. You install a program called SETI at home. It's a screensaver program. And the way we take the data from the world's largest telescope, when we break it up into little pieces, everybody gets a different piece of the sky to analyze. And you install this program, and it pops up when you go out for a cup of coffee, and the computer goes through the data, looking through all the different frequencies and signal types. This is what it looks like when it's running on your computer at home. It takes a few days to analyze that data, looking for interesting signals. And then when it finds interesting signals, it sends them back to Berkeley, and then you get a new chunk of data, a different part of the sky to work on. If you are the lucky one that finds that faint murmur from distant civilization, you might get the Nobel Prize, but there's a catch. The Nobel Prize, you have to maybe share it with a lot of people. There are millions of people that have downloaded the SETI at home screensaver. They're split up into 200 countries. Together, the volunteers have formed one of the most powerful supercomputers on the planet, and they've enabled the most sensitive search for extraterrestrial signals that anybody's ever done. So we're very grateful to the volunteers. And now we've made that more general so that you can participate in not just SETI with your home computer, but you can participate in lots of projects. There's climate prediction projects. There's a gravity wave project. There's protein folding. You can look for malaria drugs, HIV drugs, cancer drugs, and you can allocate how you want your spare computing cycles to be used on your home computer. One of the new projects that we're working on is called Panchromatic SETI, and we're asking universities and observatories around the world to look at a lot of different wavelength bands, a lot of different frequencies. We're targeting the very nearest stars, and we're trying to cover all the different bands that come through the Earth's atmosphere. We're looking at radio frequencies, we're looking at infrared frequencies or wavelengths, and we're looking at also optical frequencies, looking for laser signals. And this will be an extremely comprehensive search because we've got 8 different telescopes that we're using and looking at all these different bands, but only targeting the nearby stars. Another project that we're just launching this year is called interplanetary eavesdropping. And the idea of this project is that there may be signals going back and forth between 2 planets in a distant solar system. For instance, maybe eventually we'll have machines or people on Mars, and we'll have radio communication or laser communication between our 2 planets. Well, put it the other way, a distant civilization may have colonized a planet in their own solar system, and there may be radio or laser signals going back and forth between those 2 planets. And now with the Kepler spacecraft, we know exactly when 2 planets in a distant solar system are lined up with Earth, so we can schedule our observations and target that and see if we can intercept those signals going back and forth between 2 distant planets. We're using the Green Bank telescope in West Virginia to do that experiment. Well, we haven't found ETs so far, but we've made a lot of interesting discoveries. We discovered a planet made out of solid diamond. We've made the first maps of the black hole at the center of the galaxy. These instruments are used in all kinds of things, in brain research, which may eventually control prosthetic arms. But we haven't found ETs so far. We're still working on it. We're just getting in the game. We've only had radio 100 years. We're just learning how to do it. It's like looking for a needle in a haystack. But I'm optimistic in the long run. The reason I'm optimistic in the long run is that the SETI is limited by computing technology, which is growing exponentially. It's limited by telescope technology. China's building a huge telescope bigger than Arecibo. The Australians and South Africans and Europeans are working on a huge telescope made out of thousands of dishes combined to make a giant telescope. And I think I'll stop there. I've got a couple of poems that I could read you from the volunteers, but I'm out of time. Thank you very much.
Okay. Thank you, Mr. Wertheimer. Thank you both for your excellent testimony. And actually, you've anticipated my questions a little bit, but I'd still like to go forward with them. And let me address the first question to both of you all, but starting with Dr. Shostak. And it is this, kind of a two-part question. What do you think, and I can anticipate your answer a little bit on the basis of your statement, but what do you think is the possibility of microbial life being found in the universe or intelligent life being found in the universe? So the first question goes to the possibility. The second question would be, what do you think is the likelihood of finding either microbial life or intelligent life in the universe? Two different kind of questions. Dr. Shostak.
Well, the probability of life, of course, it's hard to estimate because what we do know now, and something we didn't know very recently, even 10, 20 years ago, we did not know, were there habitats that could support life. What astronomy has proven in the last 500 years is that the entire universe is made out of the same stuff, right? The most distant galaxies are the same 92 elements that were on the wall in your 9th grade classroom, right? So this means that if you've taken chemistry in school, you don't have to take it again if you move to another galaxy. It's all the same everywhere. We know that the building blocks are there. We now know that there are going to be plenty of planets where you have liquid water and atmosphere, the kind of salubrious conditions that you have in Hyattsville, for example, so that life could arise on any of these places. We also know that life began on Earth very, very quickly. Now, it's only a sample of one, so that's not entirely convincing, but it does suggest that it wasn't very difficult for life to get a foothold on this planet, so maybe elsewhere. So life, I think, is maybe not so hard to get started. That's sort of the general impression among scientists. But what they believe is not so important. It's finding it that's important. The second part of your question, what about intelligent life? That's a lot harder, right? The Earth has had life, we know, for at least 3.5 billion, probably 4 billion years, almost since the beginning, right? This place has been carpeted with life. And almost all of that time, it required a microscope to see it. It was all microbial. Only in the last 500 million years did you get multicellular life, eventually trilobites, dinos, you know the whole story, okay? That opens up the question, well, you know, if I give you 1 million worlds with life, what fraction of them is ever going to cook up something as clever as you all? And the answer to that is we don't know the answer to that. However, there are indirect suggestions that it will happen given enough time simply because we're not the only species that's gotten clever in the past 50 million years. If you have dogs and cats at home, they're cleverer than the dinosaurs. Intelligence does pay off.
Thank you, Dr. Shostak. By the way, you made a point that I might emphasize, and that is 20 years ago we hadn't detected a single planet outside our solar system. Now we're up to close to 2,000. So it's almost exponential growth in astrobiology research. Mr. Wertheimer.
I suspect the universe is teeming with microbial life. It would be bizarre if we are alone. But I don't know that for sure. The intelligence is going to be rarer, but because there are 1 trillion planets, I believe it's going to happen often. It's happened several times on this planet, and it's likely to arise elsewhere.
As you would put it, at 100% then?
99.
99.999, you strung on out. Okay, good. The next question, Mr. Wertheimer, let me follow up with you. And by the way, as far as the SETI at home screensaver goes, that would be something for the students here to take advantage of as well as members. I tried to adapt that to my laptop in my office several years ago and was not able to. So maybe we'll talk some more. Maybe the government needs to change its policy. I'm not sure which. But let me ask you, what are the advantages and disadvantages of radio SETI versus optical SETI?
There are lots of pros and cons. Lasers are good for point-to-point communication and lots of bits per second, lots of data. I think the best strategy is a multiple strategy. We should be looking for all kinds of different signals and not put all our money in one basket. It's hard to predict what other civilizations are doing. If you'd asked me 100 years ago what to look for, I would have said smoke signals. So we try to launch a new SETI project and a new idea every year.
Okay, and Dr. Shostak, anything to add to the advantages or disadvantages of radio versus optical SETI?
I should point out that they are both sort of different colors of the same thing. In fact, literally different colors, because they're both electromagnetic means of communication. And we use both in our telecommunications here on Earth. I suspect the aliens will as well. I have to say that just about every week I get an email from somebody who says, you guys are looking for radio signals. That's so old school. The extraterrestrials, assuming they're out there, will use something much more sophisticated than that. And I'm not sure what that is. That depends on physics we don't know. And one shouldn't discount a technology simply because it's been around a while. We use the wheel every day. That's a pretty old technology. I suspect we'll continue to use the wheel for a long time.
Okay. Thank you both for your answers to my questions. And the ranking member, Ms. Johnson, is recognized for her questions.
Thank you very much. I'm trying very hard to ask something that sounds sensible. What is the status of the extraterrestrial intelligence research now?
So I think we're just getting in the game. We're learning how to do this. And I think we'd be lucky to find, even though I'm optimistic about life and intelligent life in the universe, and it's likely there's a whole galactic internet out there, I think we'd be lucky to find them now. But I'm optimistic in the long run.
Congressman Johnson, might point out that contrary to popular impression, this experiment isn't the same from day to day. People figure we're sitting around with earphones, listening to cosmic static every day, a rather tedious job if that's what it were. But it's not. It's, of course, all the listening is done by computers. But the really important point is that much of this experiment depends on digital technology, computers, if you will. And as you know, there's something called Moore's Law, which says that whatever you can buy today for $1, you can buy twice as much for $1 2 years from now. There's this very rapid growth in the capabilities there. So, in fact, the search is speeding up, and it's actually speeding up exponentially, a very heavily overused word, exponentially, but in fact it applies.
To tell me this, I know that the improvement of technologies are important, and yet some of the old technologies or old techniques are also still in play. How do you predict your advancement based on what you have available to you for research tools?
I'll just say something. I'm sure Dan has much to add to this, but in terms of what we can do in the near future, the foreseeable future, what you really, I think, need to do if you want to have a decent chance of success, and mind you, this has to remain speculative. I mean, this is all like asking Chris Columbus 2 weeks out of Cadiz, hey, have you found any new continents lately? And his answer would be, well, there was only water around the ship today. And by the way, also yesterday, water around the ship. And tomorrow it's going to be fairly aqueous in the vicinity of the ship. Okay. But, so he can't predict when anything interesting is going to happen, nor can we. But if you look at what are called euphemistically estimates, and they are guesses as to what fraction of stars out there have somebody that you might be able to pick up, it sounds like you have to look at a few million star systems to have a reasonable chance of success. We can't do that today. We have not done that today. We've done less than 1% of that as of today. Okay? But given the predictable advancements in technology, to look at a few million star systems is something that can be done within 24 years, given the funding to do it.
Yes. Okay.
Seth captured it well.
Now, when we find the other life on other planets, what do you speculate we find, and what is the value or potential value?
I think it's profound either way. This is not an expensive thing. It's of order $1 million a year. We're funded by National Science Foundation, NASA, Templeton Foundation, some private donations. The reason I think it's profound either way, if we discover that we are alone, we better take really good care of life on this planet. It's very precious. And the other thing is profound too. If we find that we're part of a galactic community and get on the galactic internet and learn all their poetry, music, literature, science, we could learn a lot.
I'll just add briefly, nobody knows what we'll learn. If we can decode the signal, this is sort of like being confronted with the hieroglyphics. You might be able to figure them out. In the case of the hieroglyphics, it wasn't so hard. Turns out the hieroglyphics were written by humans, so that made it a lot easier. And there was also the Rosetta Stone and whatever. So we might not ever figure it out. Okay, if you could, you will be listening to data being sent by societies that are far in advance of us, because we're hearing them, not the other way around. Okay, so they're more advanced, and maybe they teach you some very important stuff. Who knows? I mean, imagine that the Incas find a barrel that's washed up on the shore, maybe from Europe, and it's filled with books. If they could ever figure out the books, they would learn a lot of interesting stuff. I don't know that we will ever figure out the books, but even if we don't, the important point has been made, and that is we have calibrated our place not in the physical universe, we've sort of done that, but calibrated our place in the biological and even more the intellectual universe. And I think that that's maybe good for our souls to know how we fit in.
Thank you very much. My time is expired.
Thank you, Ms. Johnson. The gentleman from Ohio, Mr. Johnson, is recognized for his question.
Thank you, Mr. Chairman. Gentlemen, for both of you, how has the recent discovery of over 1,700 planets by the Kepler Space Telescope, how has that impacted SETI research?
If you'd asked astronomers 20 years ago, are there planets going on other stars, we said, well, we think so, but we don't know. And that's all changed now. And a lot of it's due to NASA's Kepler mission. And if you extrapolate on the planets, which are a few thousand planets that they've discovered, if you extrapolate on that, there are 1 trillion planets in the Milky Way galaxy. That's about 3 or 4 times more planets than there are stars. So that's a lot of places for life.
Okay.
I think that it's also affected the experiments in the sense that in the past we would point the telescopes in the direction of stars, certain kinds of stars, certain masses of stars, certain brightnesses of stars. Those stars were the ones that we thought these might have an Earth-like planet, but we didn't know. We now know 2 things. One, as Dan has just mentioned, we know that the majority of stars have planets. So you can just look at a random star and feel fairly confident it has a planet. But more than that, we're beginning to get some indication from Kepler what fraction of stars have planets that are sort of like the Earth. And that fraction is not 1 in a million. It's not 1 in 1,000. It's not 1 in 100. It may be 1 in 5. So you look at 50 star systems and you've examined 10 Earth-like planets. So in some sense, it's made the search much more straightforward. We just look at all the nearby stars we can.
Okay. Well, Dr. Shostak, would you please provide some examples of the technical contributions that SETI has made to astronomy and other fields? For example, how has SETI research benefited other areas of science?
Well, I think that its benefit is less so in terms of the discovery. Obviously, we haven't found ET. If we had, we wouldn't be having this hearing, okay? But, and to my surprise, I have to say, SETI has not turned up any astrophysical phenomena that were unexpected as well, okay? And that's surprising. Normally, the precedent in astronomy is that every time you build an instrument that examines a different, if you will, parameter in the phase space of the universe, you find something new. So that's instructive that it hasn't. The kind of technology that has been developed is certainly of interest to other fields in astronomy. But I think the real value of SETI is not so much in terms of what it does to astronomy, but what it does in terms of the other efforts being made to find life in space. NASA has a big effort. The rovers on Mars, yes, they're there to find the hydrology, the history of water on Mars. But why are you interested in the history of water on Mars? You're interested because you want to know, were there ever Martians? Microbial, most likely. Or are there still Martians? That's what interests people the most, okay? And SETI was always, if you will, a punchline to this story that NASA had about finding, the traces of water on Mars or burrowing through the ice on Europa, Enceladus, some of these moons of the outer solar system where there may be vast quantities of liquid water, that sort of thing. SETI was always that, okay, life, we may find life, but what about intelligent life? That would be even more interesting. And that's what's missing, in fact, from the NASA program today. Okay.
You made a comment just a few minutes ago that kind of caught my attention. Let me make sure I got it right. You said that if we hear from intelligent life out there somewhere, that they must be more advanced than us because we're hearing from them and not the other way around. How can you draw that conclusion? I mean, maybe they've been hearing from us for a long time and just don't like what we have to say.
Mm-hmm. I think it's entirely possible that we are in their catalog. They've seen oxygen in our atmosphere, and they know we're out here. And I think that life in the universe is going to be there's going to be lots of different stages. Some of it's going to be microbial, some of it will be trees, more sophisticated. The Earth is 5 billion years old. Some stars are 10 billion years old. So there could be a lot of advanced civilizations as well.
Mm-hmm. Okay.
Just point out, you're not going to hear from any less advanced societies and not building radio transmitters.
Well, yeah, I'd
That's for sure.
I'd say at least equal to, perhaps more advanced, but you know, maybe they got their caller ID block turned on or something.
It could be. I wouldn't speculate on alien sociology and whether they'd like our television or not. So I don't know about that. But the chances that if they're at least at our level, that they're within 100 or even 1,000 or even 10,000 years of our level is simply on statistical grounds highly uncertain. If you hear from somebody, they're way beyond you.
Yeah. One final quick question for both of you. How would you define successful SETI research? I mean, I know that's kind of a nebulous question,
Mm-hmm.
but
Finding
how
the
would you
signal.
define it successful?
If you found a signal, and that could be corroborated, if you just find it once and you can't find it again, it's not science. So if you find a signal that's moving across the sky the way the stars do because of the rotation of the Earth, it's a narrowband signal, it's not made by nature, it's made by a transmitter, that's success.
Right. Okay.
Right. I think the most likely scenario is finding some sort of artifact of their technology, a radar signal or a navigational beacon or something that won't contain a lot of information, but we'll know we're not alone.
Okay.
Okay. Thank you, Mr. Chairman. I yield back.
Thank you, Mr. Johnson. The gentlewoman from Oregon, Ms. Bonamici, is recognized for her questions. And if the gentlewoman will just yield to me for 10 seconds.
Certainly.
It was mentioned a while ago that the likelihood is if there were other intelligent civilizations, they would likely be far and more advanced than we are. We're a relatively junior galaxy. They might be 2 billion years older than we are. And it's just fascinating to think what form of life might be existent in a universe or parallel universe or another galaxy where they've had a 2 billion year head start. We might not even recognize the sentient beings. We might not be able to communicate with them. But that's just one of the reasons we're fascinated by the subject, and none of this will be counted or charged against the gentlewoman's 5 minutes for questions.
Thank you, Mr. Chairman, and thank you so much, Dr. Shostak and Mr. Wertheimer, for being here. I noticed in your testimony, Mr. Wertheimer, that you said that there are 24 SETI scientists on the planet, and I can't think of a time in this committee where we've had a larger percentage of experts on our panel. So thank you both so much for being here. I really appreciate it. And Dr. Shostak, I really am intrigued by your section in your testimony on the public's interest and how the idea of life in space is an idea that everyone grasps and is especially an ideal hook for interesting young people in science. I think that's evidenced by the full committee room today. One of the statements that resonated with me is it would be a cramped mind indeed that didn't wonder who might be out there. I really appreciate that. You said also in your testimony, extraterrestrials are the unknown tribe over the hill, potential competitors or mates, but in any case, someone we would like to know more about. And I recollect a similar hearing in this committee, I believe it was last year, when one of my colleagues, and I'm fairly certain it was Representative Chris Smith, who's no longer on the committee, said, the interesting question is, what do we do when we find the life on another planet? So can you talk, both of you, about what's the plan? Do we announce it to the world? Do we do research more to determine if these are friendly or collaborative? Or what do we do when we make the discovery, assuming that it's going to happen? Dr. Shostak, would you like to begin?
Yes, that's a question of great interest to the public and of great importance as well. To begin with, there's no danger, right? I mean, you tune in your favorite DJ here in D.C. on the car radio, and there's no danger that that DJ is going to jump into the car next to you and give you a hard time because they don't know that you picked them up. All right, so if we pick up a signal, they don't know that. All right, there is the question of, well, should we reply? I'll get to that in just a second, but what happens then? Suppose we do pick up this signal. It would be announced. The public has the idea that you all have a secret plan, that the government has a secret plan for what to do if we pick up a signal. As far as I can tell, there is no plan, okay? And we have had false alarms, and I've waited for my congressman to call me up and say, hey, you guys are picking up a signal. What about that? And nobody in the government shows the slightest bit of interest, to be quite honest. What happens is that the media start calling up. The New York Times will call up. right? But the media, or sorry, the government is not so interested. So what would happen is that it would immediately be known that we had found the signal, and it would be known even before it had been corroborated. So there are going to be false alarms. Be prepared for that. But what you do is you get somebody at another observatory to also observe it. You would not believe it yourself if you were the only ones to find it. There are too many things that could go wrong. Okay.
Mr. Wertheimer, do you have anything to add to that?
Yeah. I think before you make a big announcement, you want to make sure it's real. You ask a telescope with different people, different software, different equipment to see if they can verify it. Then you can triangulate, make sure it's coming from something outside. You make sure it's not a graduate student playing a prank on you. And once you have some confidence that you found something, you may not know what it is. It could be some new astrophysical phenomenon. When pulsars were discovered, they thought maybe they'd found little green men. So I think at the point where you're pretty confident that you found something, you make all the information public, the coordinates in the sky, the frequency, anything you know about the signal. And I think there'll be a lot of debate about whether this is some new natural phenomena or whether this is really evidence of another civilization. A lot of people will be working on that problem.
And could you also address, of the 24, you say the 24 SETI scientists on the planet, to what extent are other nations involved? How collaborative are we? We have a lot of discussions in this committee about international collaboration, especially in space. So can you talk about where we are as a nation compared with the other countries in the world?
Yeah. SETI is quite fragile. As you said, there are 24 people doing it. There are about 2/3 of them in the U.S. The U.S. is leading this effort, and a lot of the original ideas have come out of the U.S. But we are working with other scientists in other countries, and because it's so fragile, we're trying to train new people and get new ideas and get other groups, because it's only at a very small number of institutions right now. The funding is fragile too. It's fluctuating around. The two biggest telescopes on the planet are currently funded by the National Science Foundation, the Green Bank Telescope in West Virginia, the Arecibo Telescope. Those are in funding jeopardy. It looks like one of those observatories is probably going to have to be shut down. The other is just hanging by a thread. The Chinese are building a bigger telescope. There's a new one going to be built in South Africa and Australia. So the U.S. may not continue to lead this work, but it is now.
I would find that disappointing if that happened. And I'm out of time. I yield back the balance of my time. Thank you, Mr. Chairman.
Thank you, Ms. Bodemici. And the gentleman from New York, Mr. Collins, is recognized for his question.
Thank you, Mr. Chairman. I think I might ask the question everyone in this room wants to ask. Have you watched Ancient Aliens? And what's your comment about that series? We'll start with you, Dr. Shostak.
Yes, I think I've been on it, actually. More than once. Look, the public is fascinated with the idea that we may be being visited now or may have been visited in the past, the so-called UFO phenomenon. I personally don't share the conviction that we are being visited. I don't think that that would be something that, all the governments of the world had managed to obfuscate, to keep secret. I don't believe that. But the idea that maybe we were visited during the time of the ancient Egyptians and so forth. Keep in mind that in the 4.5 billion year history of the Earth, the time of the ancient Egyptians was yesterday. Right. So again, why were they there then? What was it that brought them to Earth? I have no idea, and I don't find very good evidence. I think the pyramids, for example, were probably built by Egyptians. I know that that's a radical idea for some people, but they were very clever, and they could certainly do that. So I don't think that there's any good evidence that convinces me that we were visited in historic times.
How about you, Mr. Wertheimer?
UFOs have nothing to do with extraterrestrials. So even though I'm optimistic with life, there's no evidence that any of these sightings. I think some of these sightings are real phenomena. We get a lot of calls when the space station goes over, although some people embellish and they say it has windows and things. And some of it is people's imagination, and we know that because it ties very closely to popular culture. When Jules Verne wrote about flying saucers, everybody started seeing flying saucers. Before that, people saw angels. When people watch movies, then we get a lot of reports that are tied to what's in the movies. And some of it is actually deliberate hoaxes, for people making money.
Yeah. Thank you. I think that was my only question, Mr. Chairman. I yield back.
Thank you, Mr. Collins. The gentlewoman from Maryland, Ms. Edwards, is recognized for her questions.
Thank you, Mr. Chairman. I feel like I should have been here earlier, so I apologize. I've enjoyed the discussion thus far, and reading the testimony, my favorite movie is Contact, right? So every year it comes out since 1997. I watch it, I dream, I think, well, who knows. What's intriguing about this conversation is the idea that, and it's a little bit of hubris, right, that somehow we're waiting to find them as opposed to them finding us. And maybe that's just the nature of Homo sapiens. That's kind of what we do. But I'm a little bit curious, Dr. Wertheimer, in your prepared statement, you discussed the Panachromatic SETI project, which will use 6 telescopes to search nearby stars and stars most likely to host an exoplanet system similar to the Sun's. And so the project, as you describe it, would examine a large portion of the electromagnetic spectrum spanning from low frequencies through optical light to detect possible signals from advanced civilization. How are the target stars that you talked about identified, and how are you going to coordinate the use of the 6 telescopes?
We are not trying to use the telescopes all at the same time. That's actually hard to do. So we just use a telescope, and other groups we're working with a lot of groups at universities and observatories. But typically we'll use one telescope, and then a month later we'll use another telescope, and so on. The stars that we're targeting, we instead of targeting stars that we know have planets, because of Kepler spacecraft, it looks like all stars have planets. So we're just going to target the nearest stars. And so that's our plan, is just target the nearby stars.
Right, and you talked also about the, this notion that there are just sort of 24 of you folks, most interested, robustly, academically, studying this. But aren't there like there's a whole network of people out in communities who kind of feed or fuel some of the research that you're doing?
Seth, you want to take that one?
Dan refers to me because I don't think we know the answer to that question. In order to do this, it would be like saying, sure, there are a few thousand people looking for the Higgs boson, but what about the communities that are feeding that? If you don't have the instrument, it's very hard to do the experiment, and the number of instruments involved here is very small.
So the rest of us are really just, dreaming and pretending that that's what we're...
Well...
That's all right. You don't have to answer that. I was not serious at all. And then I want to talk about security issues in the time that we have left. I understand that early on there was an assessment of the robustness of the SETI's home software to withstand malicious attacks and penetrations. And in the earlier study, you found that there had been 2 noteworthy attacks and the web server was compromised. And you also found later that exploiting a design flaw in your client-server protocol, that hackers had actually stolen thousands of user email addresses. Can you give us an idea of the current state of security?
Yeah, I think in general, downloading software and installing on your computer, you should be careful. It actually turns out that SETI at Home is one of the safest things you can install on the computer, and the reason is because millions of people are using it and testing it out. And also it's been running for a really long time, and it's open source software. The software is, anybody can read the software and help us. A lot of the volunteers actually help us write the software, and we're now porting it to cell phones, so you can run it on a cell phone, which will allow us, a lot of people, even more people, to participate in the search.
I guess some of the question is just the challenge, especially whenever you deal with open source, the challenge of the system's vulnerability.
Yeah, I actually think open source software is actually a little safer because so many eyeballs can look at it.
Okay, I'm done. I think I'll just go back to watching my movies.
Thank you, Ms. Edwards. The gentleman from Florida, Mr. Posey, is recognized for his questions.
Thank you, Mr. Chairman, and thank you for inviting these distinguished witnesses for this fascinating testimony. Very enjoyable. I go to the SETI Facebook page every day to get a little extra factoid. Learn something every day. I hadn't been there a single day to find that I already knew your message of the day. Very, very educational, very inspiring, obviously very interesting, and graphics always good too. And I want to thank you for that. On your disclosure, I was really impressed with the number of agreements and grants. I'm just really glad to know that NASA is so engaged with what you're doing there, and still allow you all to have a pretty free hand to do what you do better, I think, than anybody else is doing it, obviously. And so thank you for that. Obviously, there's some curiosity about your thoughts about such things as Project Blue Book. What do you think?
First off, I want to thank you for noting all those grants, by the way, are for the astrobiology research being conducted at the SETI Institute. Yeah. There's actually no federal money going to the search for intelligent life, right. But the majority of our scientists are doing astrobiology, so life on Mars, the outer solar system. In terms of project,
and we're glad you are.
Yes, well, so are we, I can assure you. And that's, I think, a very productive line of research as well. In terms of Project Blue Book and the whole UFO phenomenon, as I say, I am personally quite skeptical. 1/3 of Americans believe that we are being visited. That's the result of polls that have been taken since the 1960s. That number doesn't change. And by the way, if you think this is a especially American opinion, that's wrong. 1/3 of Europeans, Australians, Japanese, and so forth believe that we are being visited. I do not. I honestly do not. I don't think that evidence is very good. I think that if we were being visited, it would not be controversial. It's been 60-some years since Roswell, for example. If you would ask the residents of Massachusetts 60 years after Columbus, do you think you're being visited by Spaniards? That would not be controversial. Yeah. I think that if they were really here, everyone would know that.
Okay, very good. Stephen Hawking, I believe, made some comments about contact with extraterrestrials or other life. Your thoughts about his comments?
Yeah, so this is a controversial topic about whether we should transmit messages. That's called active SETI or METI, messages to extraterrestrial intelligence. Most people in the field think that we're just an emerging civilization, and the first experiments we should do is just listening, trying to receive signals and see what's out there. We think that advanced civilizations are going to be peaceful if you watch Star Trek, but we don't know that, and that may be naive. So my feeling is that we should be just listening for now, and maybe in 1,000 or 10,000 years, if we don't hear anything, we should think about transmitting signals. But that's a question for all humanity. It shouldn't be just up to a few scientists, and so that's a big decision about who should speak for Earth. So right now, I think we should be listening, and I believe that's what Hawking would say as well.
I'm going to disagree a little bit with my colleague here, Dan. I think that there's very little danger in transmitting, and if there is, we're already doing it. Yes, we're not deliberately targeting the stars in general, although we have done that in the past. NASA sent a Beatles song in 2008, I believe it was, to the North Star. And it'll take 450 years to get there, and they may or may not like the Beatles. But, they use a fairly powerful transmitter. But the most powerful transmitters are coming off the airports, right, for air navigation, for the dew line, all these things. These signals are on their way into space. They've already reached several thousand star systems. Any society that has the technical competence to threaten you across dozens, hundreds, thousands of light years of space, any society at that level can pick up these signals. So if you're really going to worry about this, you better shut down all the radars at the local airports. And personally, I don't think that would be a very good idea. Okay.
And briefly, still related, your thoughts on thorium?
Sorry, I'm not familiar with the topic. Are you talking about nuclear reactors on thorium?
Yeah.
I'm really not an expert. I'm sorry.
Only this. If you're talking about powering spacecraft this way, if you send spacecraft to some of the more interesting parts of our solar system, they're in the boondocks of the solar system, out to Jupiter, Saturn, and so forth. When you get to Saturn, the amount of sunlight is dropped by a factor of 100. So you can't use solar cells very effectively out there. You have to power the craft some way. I wouldn't worry too much about radioactivity in space, of course, because space has plenty of radioactivity. Right? That's the nature of the cosmos. Right? But if you're worried about the fact that these launches could go awry and that you would land these things on Earth, yes, that's a danger. But, of course, people are aware of that danger, and they try and mitigate it.
Okay. Thank you, Mr. Chairman, and thank both witnesses.
Thank you, Mr. Posey. The gentleman from Arizona, Mr. Schweikert, is recognized for his question.
Thank you, Mr. Chairman, and to our witnesses. So let's see, what have we learned so far? We've learned there's a chance the aliens don't like the Beatles, which I have trouble imagining, and they don't like our television programming, and there was a couple other things. Oh, yeah, and Contact is the best movie, right? Somehow I thought that would be funnier. A couple mechanical questions. I just want to sort of get my head around some of the current scientific understanding. Let's walk through a scenario, and you tell me if it's plausible or this is current thought. Asteroid hits the world, hits our Earth, and rock is thrown out into the stellars. It carries DNA. Does that DNA survive? Doctor?
Yes, this idea, known as panspermia, and I'm sure you're aware of that, the idea that one world could infect another world has been looked at. People have actually simulated the environment of space and put some of our earthly bacteria into a rock and put it, as it were, in space to see how long they could survive. For example, would the DNA still be viable when it got someplace interesting? And the results, as I understand them, suggest that, yes, if you're talking about communicable disease, if you will, within the solar system, could a rock from Mars have seeded the Earth? That is possible. There's no evidence that that occurred, but that is possible. The life would survive. It would remain viable over the kind of time scales to send rocks in the solar system from one world to another. But if you're talking about seeding worlds in other solar systems at the distances of the stars, the problem is space is a pretty harsh environment even for a rock because there's a lot of radiation and it's incredibly dry. So anything that's in there is going to be suffering desiccation for maybe hundreds of thousands, millions really, of years before it gets there. And the general consensus that I've heard is that it won't be viable when it does.
Thought on that? Because I think that's the current sort of thought right now.
Yeah, so as you know, asteroids have hit the Earth many times. And so it'll be a really interesting question if life is found in our own solar system, like, for instance, Europa, which is a moon going around Jupiter, has a liquid ocean. There could be something swimming around down there. By the way, when I talk to elementary schools and I ask them how are we going to get through the ice and see if there's something swimming around down there, the boys all say we should use machine guns and bombs, and the girls say we should melt our way through using mirrors. A little different. But anyway.
Once again, proving there is something in our DNA makes us different.
So if we do find life in our own solar system, it would be really exciting to figure out, is it exactly the same kind of life? Does it use the same DNA, the same amino acids, the same nucleotides? Is it identical chemistry? That would mean that rocks are going back and forth between these moons and planets in our own solar system, and it really happened in one place and was carried back and forth, as Seth was talking about. That's not very interesting. What would be much more interesting would be discovering life that's different, with a different chemistry, because if we do find something like that on Europa or another moon or Mars, that means that the universe is teeming with life. If we can find it in two different kinds of life in our own solar system, that means there's a lot of life out there.
Yeah, it makes the imagination wonder. Earlier, the chairman, and I mean this with all the love in the world, was trying to say, give me a percentage of life out there in existence. I remember doing this sort of as a sort of thought process with one of my professors many years ago. And I guess one of the mechanisms was, from the beginning to today, Earth has had 100 billion species or something like that, and how many can do higher math? And sort of give you sort of and we would use that as sort of a benchmark to try to do those calculations. And I guess our understanding was it's unknowable, of what's out there, what isn't out there. I mean, we see the world of large numbers, large planets, these huge numbers.
Mm-hmm. On Earth, intelligence has arisen several times independently. There are a lot of intelligent creatures, although none is quite as intelligent as us, maybe. We're not sure.
Well, we always use the higher math as the...
Yeah. But My guess is that on some planets there are going to be selective pressures that select for different kinds of things. You can be successful in life if you're strong or fast, but you can also be successful in some evolutionary environments by being smart. And so I think there are going to be places in the universe where it's advantageous to be smart.
But I guess, and for Dr. The fun on this one is, how would you ever calculate it? How would you ever sort of build your baseline to build from? And when you move from sort of hope, which is a powerful thing, to being able to put it into a calculator, there is often quite a leap there.
I think it's very difficult to estimate because we just have this one example on Earth. And so I think the only way we're going to find out is to do this search.
It's very akin, I think, to sitting around in the bars of Europe in 1700 trying to estimate the probability that any expedition sent into the deep south, any sailing expedition, will find the hypothesized southern continent there.
No.
You know, what are the probability? Can you give me that to 3 figures before I fund you? You can't.
Yeah. So
you have to do the experiment.
So therefore, it becomes a leap of faith. But
it's a reasonable leap of faith. It's a reasonable hypothesis that there's life to be found out there, even intelligent life to be found out there. And we can sit around and have a lot of drinks and talk about it, but in the end, if you don't do the experiment, you'll just continue to have the drinks.
Oh, seeing some of our questions, there may have been a lot of drinks going on. Thank you, Mr. Chairman.
Thank you, Mr. Schweiker. Dr. Shostak, Mr. Wertheimer, thank you both for your testimony, which was clearly appreciated by both members of Congress as well as the audience. And I also want to thank the Herndon High School students for being here today. You had a wonderful opportunity today to hear about a fascinating subject, and I hope this will spur you on to study not only astrobiology but other scientific subjects as well. And in case someone has an interest or wants to follow up on this subject, you might go to our committee's website, which is science.house.gov, and we'll clearly have some information about this hearing on that website as well as other things that might be of interest to you all. So thanks again for a wonderful hearing today, and we stand adjourned. Called Kepler 186f. It is only 10% larger than the Earth and about 490 light years away. The Transiting Exoplanet Survey Satellite, which will launch in 2017, and the James Webb Space Telescope launching in 2018, will help scientists discover more planets with potential biosignatures. The United States has pioneered the field of astrobiology and continues to lead the world in this type of research. A sample of professional papers published in Science magazine between 1995 and 2013 illustrates the significant growth and growing popularity of the field of astrobiology. Between 1995 and 2012, the number of papers published on astrobiology increased 10 times, and the number of scientific reports that cited astrobiology increased 25 times. Astrobiology is a serious subject studied by serious scientists around the world. Reflecting this interest, next September, the Library of Congress and NASA will hold a 2-day astrobiology symposium on what the societal impacts could be of finding microbial, complex, or intelligent life in the universe. Whether life exists on other planets in the universe continues to be a matter of debate among scientists. Around the world, a number of astronomers listen to naturally occurring radio frequencies. They try to filter out the cosmic noise and interference of human-made satellites and spacecraft to Before we start, let me say to you all who are standing up, who I assume are students at Herndon High School, is that accurate? Any chair that is not now occupied, you all should feel free to take. So if you want to come forward, you can fill up some of these seats in front or in the back right there as well in the middle. I don't want you to have to stand up this entire hearing. Of course, the students sitting in the chairs that say reserved for witnesses might be called to testify, but that's the chance. That's the chance you take. The Committee on Science, Space, and Technology will come to order, and welcome to today's hearing, Astrobiology and the Search for Life in the Universe. A couple of preliminary announcements. One is that I want to thank C-SPAN for covering this hearing today. That shows the importance of the hearing and will find anomalies that could be signals from civilizations elsewhere in the universe. The Allen Telescope Array at the SETI Institute, financed by Microsoft co-founder Paul Allen, and the Arecibo Telescope in Puerto Rico are two well-known locations for conducting radio astronomy searches for life in the universe. Recently, radio astronomers have detected pulsed signals that last only a few milliseconds. These fast radio bursts, as they are called, have caused scientists to speculate as to their cause. Some scientists hypothesize they could be from stars colliding or from an extraterrestrial intelligent source. Other astronomers search for laser light pulses instead of radio waves. Researchers at the SETI Optical Telescope, run by the Harvard-Smithsonian Center for Astrophysics, the Columbus Optical SETI Observatory, and the University of California at Berkeley, among others, use optical telescopes to try to detect nanosecond pulses or flashes of light distinct from pulsars or other naturally occurring phenomenon. I hope today's hearing will enable us to learn more about how research in astrobiology continues to expand this fascinating frontier. The unknown and unexplored areas of space spark human curiosity. Americans and others around the world look up at the stars and wonder if we are alone or is there life on other planets. That concludes my opening statement, and the ranking member, the gentlewoman from Texas, Ms. A lot of respects. And I want to thank all the students from Herndon High School here as well. I understand you had a choice of hearings to attend. In fact, you could attend almost any hearing you wanted to, and you chose this one because you thought it was the most interesting. And actually, that is one of the purposes of today's hearing, and that is to inspire students today to be the scientists of tomorrow. And who knows, we may have some of those scientists in the audience right now who will be inspired by what they hear to study astrobiology or perhaps some of the other sciences as well. So we appreciate your attendance. I'll recognize myself for an opening statement and then the ranking member as well. As we discover more planets around the stars in our own galaxy, it is natural to wonder if we may finally be on the brink of answering the question, are we alone in the universe? Finding other sentient life in the universe would be the most significant discovery in human history. Scientists estimate that there are 80 billion stars in the Milky Way galaxy. To date, more than 1,700 nearby planets have been found by the Kepler Space Telescope. Last month, astronomers discovered the first Earth-like planet orbiting its star at a distance where liquid water could be present, a condition thought essential to life.